Well, good afternoon. I'm super excited to be here. I'll be talking mostly about airplanes and faster future, and have just only a few words about airports, mainly in the way of some thinking about what does the airport become in a supersonic age, but we'll save that for the end. As we get in, how many of you got here on an airplane? And how many of you, that flight was more than 2 hours? More than 3? More than 5? 8? 10? Wow, okay. I'm super honored to be here given how far you guys have flown to come be at this event. Those of you who've been on the long flights certainly know intimately how much better it would be if we could spend less time on airplanes and more time living on the ground. But before I talk about faster flight, I want to spend a little bit talking about the history of speed and why we think this is important and why it matters. And I want to start out with the story of two children and their grandfathers. So the first was a little boy who grew up in Cincinnati, Ohio, and his grandpa was a World War II veteran, a self-made man, and he was lucky. He lived just an hour and a half away in rural Indiana, and so they got to see each other every weekend and became close. And the second are a little girl and two boys who also have a special grandpa, a self-made man who started a real estate empire and hospitality businesses. But unfortunately for them, their grandpa lives 16 hours away from them in Hong Kong. And so they see each other only once a year, and despite so many life lessons to be shared, they'll never become close. So if you haven't figured it out yet, I was a little boy, and those kids are my kids now. And what I find really tragic is that the airplanes we have today are no faster than the ones we had when my parents were growing up. We've gotten no better at shrinking the world, and this has real human consequences that we've failed to conquer geography. To really appreciate this, let's look back through the history of speed. So for most of human history, all but really a tiny sliver recently, we've gone only as far as our feet could carry us. And what that means is most people will be born, live out their entire lives, never venturing more than 20 miles from their birthplace. And of course, journeys across continents would take lifetimes. But recently, we've made some progress. By the 1840s, if you lived in the eastern United States and you thought of going west, you'd take a covered wagon. And the journey was, of course, about 6 months. And there were only one-way tickets. You didn't visit, you moved, right? And in 1869, we had a breakthrough invention in the transcontinental railroad. And that journey that took months by a covered wagon now took just 83 hours on the train. Now, of course, 83 hours doesn't sound like much by today's standards. But for the first time, you could go round trip. You could visit somebody in California and come back as a New Yorker. And progress continued to accelerate. In 1903, as we all know, the Wright brothers flew the first airplane. And it took just 30 years from that first airplane to regular transcontinental service. So that 83-hour journey on a train now shrank to 20 hours on an airplane. But let's zoom in very carefully on what happened when we went from propeller aircraft into the jet age. So in the 1950s, if you lived here or in San Francisco and you dreamed of an island vacation in Hawaii, you'd get on one of these. That's right, it's a flying boat. And the journey would take you about 16 hours. And consequently, most people, when they found that out, would say, let's go to wine country. Because it just doesn't make sense to go when the journey is so long. But the jets changed all of that. That 16-hour flight shrank to just 6 aboard a jet airplane. And what happened is in the first 10 years of the jet age, travel to Hawaii went up 6-fold. And it just kept on going up as we started to build hotels and resorts and tourist attractions. And people started to reconfigure their lives around this remote, exotic, unreachable place suddenly being open to the world. And the same thing happened all over the place. Wherever you look at the data, you see a skyrocketing in travel as faster travel becomes available to people. But it wasn't just about where you could go. It was also about what could come to you. Like the Beatles. The Beatles took the first world tour in 1964, a tour that would not have been practical just 10 years earlier with slower airplanes. So the jets contributed to music really becoming global. And also Major League Sports. Before the jet age, baseball was confined to the northeastern US. is when it takes a day to get across the continent, you can't get the teams together to have enough games in a season. But within 6 months of the first transcontinental jet service in the US, the Brooklyn Dodgers became the LA Dodgers, and baseball spread from coast to coast. So next time you enjoy the big game, give thanks to the jet, whose speed made it possible. Now, this was in the 1960s, and of course by the end of the 60s, we had what looked like even more progress in aerospace. In that year, we put a man on the moon and brought him home safely. And around about the same time, we flew Concorde for the first time, a faster than the speed of sound airliner that was to be to jets what the jets had been to the propeller aircraft, or the propeller aircraft had been the train, and so forth. But something strange happened. We did have Concorde, finally entered service in 1976. But with sky-high fares, about $20,000 round trip New York to London, it wasn't affordable to many people, and it never really changed the way we got around the planet. And so after nearly 30 years of flying, in 2003, we shut Concorde down with no plan to replace it. Isn't that strange? And now looking back on it, the two things we had in 1969, moon rockets and supersonic airplanes, are only found in museums. And this is a pretty crazy story, because where else in technology do you have a capability and then you lose it and you go backwards? And so to understand how we can bring back supersonic travel and do it not just in a way that's kind of for a few people, but do it in a way that really changes the way we access the planet, I think helps to take a look back at those first few breakthroughs in airplanes and look at where they came from and what lessons did we have to learn about how to do supersonic right. So let's look at some of those first few breakthroughs. Everyone knows first airplane came from bicycle entrepreneurs who wanted to fly and thought there could be some commercial potential for their invention. But what's less well known is the first really practical airliner, the DC-3, and the first jetliner, the de Havilland Comet, were also created by relatively young founder-led companies. That is, these airplanes were all made by startups. But it's been 95 years since anybody has started a company that went on to build commercial aircraft. We haven't had startups in this space for a long time. Concorde did not come from a startup. It didn't even come from an established company. Concorde was a joint venture between two governments, the French and the British. After all, most joint ventures between the French and British have been wars. So it's remarkable this worked at all. But remember, the Concorde Treaty was signed in 1962. It was the height of the Cold War, and the motivation was not, let's build a mass market supersonic jetliner. The motivation was, let's beat the Soviets into the supersonic age. Same as Apollo. And so actually the Soviets got there first with the Tu-144, or Concordski, as some people like to call it. But this airplane had all kinds of problems. They flew it at an air show a couple times, crashed, carried passengers a couple times, put some mail on it, and called it done. And there was an American competitor too, championed by Kennedy, built by Boeing, funded by taxpayers. This was supposed to be a Concorde killer. Instead of 2 times the speed of sound, this is going to be 3 times. It's going to haul 300 passengers. Got canceled. And then finally, we only had Concorde actually entering service in 1976. But in my view, Concorde was really stillborn. It came from the Cold War era goals, where it was about national prestige, not about practical economics. And thus, 50 years later, we have these things that look like incredible progress in transportation. They look like a new era of space exploration, high-speed travel is what we had to look forward to. But we quite literally planted flags, and we did things that were technically impressive. But we didn't, without a commercial approach, we didn't have a sustainable model. And what's different about doing this as a company is you have to come up with a model where it works for passengers. You've got travel at a price people can afford. It works for airlines, and they can see a way to make money operating the aircraft, and then a big enough market that you can make a return for your investors. And when you have projects that are free of that, you don't necessarily get anywhere. So I started looking at this in a very serious way personally about 3.5 years ago. I've been dreaming of supersonic flight for a long time, and I thought I got to look at this, and I'll probably learn a couple things, get it out of my system, and move on and work on something else. But what I learned was something really surprising and actually quite exciting. While we haven't had a speed up in air travel for half a century, we have had 50 years of progress in the basic way we build airplanes. And when you put all those technologies together, it turns out we have the fundamental building blocks we need to do this today in a much more mass market way than Concorde. Not quite yet for everybody, but to do it with kind of business class kind of prices, which is a big market. And maybe that could be kind of a foothold towards a more mainstream renaissance in speed. And I'll talk a little bit about some of those advances. So in Concorde's time, when you were developing a new airplane, you had to do all your work in wind tunnels. And so you build a wind tunnel model and test it, blow the air, take a bunch of data, learn something, then go back and do a design iteration. And that whole process would take months, like 6 months. And it costs millions and millions of dollars. As a result, you can't test very many iterations. They did about a dozen on Concorde before it was time to say, okay, well, that's good enough, we'll go build the airplane. But today we've got computer simulation. This stuff called computational fluid dynamics was virtual air. And you can do 6 months of wind tunnel testing in about 30 minutes of cloud computing time. And it costs approximately pocket change, so you can do it on a startup-sized budget. You get way better visualization than you can in a wind tunnel. And what this really means from an engineering perspective is you can test a whole lot more designs, and most of them turn out to be stupid. But you find a few that work, that are more efficient, that give you more lift for less drag, which means less fuel, which means more affordability. And this is an example kind of simulation result of our airplane. If you look closely, you can tell there's kind of no straight line anywhere on the aircraft. If you had to build this out of 1960s technology out of aluminum, it'd be incredibly cost prohibitive to make all the stamping machines you would need for all those kind of custom shaped components. But it turns out today we've got carbon fiber composites. And carbon composites are a big deal for supersonic for a couple of reasons. One is the way you build a carbon part, as probably many of you know, is you don't sort of machine it, you make a mold, and then you lay up your layers of carbon fiber and you cure it. And so what you get is this strong, lightweight part that's exactly the shape you want it. You can make the mold in any shape, any part you want. And so that lets you build a very, very complex shape efficiently. And there's another reason it matters too, which is pretty cool. Or actually, I guess technically it's hot. The faster you go, the hotter the airplane gets. Concorde was limited to about twice the speed of sound because any faster, it would have gotten so hot that the aluminum would become kind of mushy. And you don't really want to fly around on a mushy airplane. It turns out this carbon composite stuff stands up to hundreds of degrees really easily. So it's no longer thermally limited in speed, and it doesn't grow. We were talking with some folks before the talk about aluminum. When it gets hot, it gets bigger. Concorde grew about 15 inches in flight, and it's challenging to design an airplane where the outside gets bigger, while the inside needs to stay the same, and it's still supposed to be airtight. So carbon doesn't really grow, so that's easier. And then there's a kind of a last thing that's probably actually the most significant, which is engines. Concorde was the only commercial aircraft ever to fly with an afterburner. And if you're an airplane geek like I am, and I imagine a lot of airplane geeks in this room, afterburners are so cool because there's like a flame kind of at the back of the engine, right? They're beautiful, especially at night, and you can't miss them because they're so rip-roaring loud they turn heads. But if you're an airline, you don't really like afterburners because it's like the engine's on fire. It's like fire in the engine. That's scary. And then people are calling their congressman and complaining about noise because they're so darn loud. And perhaps most important, they're very fuel inefficient. On Concorde, when they'd flip on the afterburners, it was about 78% more gas for 17% more thrust. So it's just a bad way to get thrust. Now, they weren't stupid. They were just working with really the best of 1960s technology, and that was the only way you could get enough thrust to go really fast. But it turns out there's nothing magic about afterburners. You just have to have enough push to get over the drag of higher speed flight. And now we build jet engines, of course, completely differently. We have something called a turbofan. That's what this is. This is a cutaway of what powers the 787 aircraft. and they're dramatically quieter, they're much more efficient, and you can take basically a commercially available turbofan and adapt it for high-speed flight. Instead of having a big fan on the front, you put a medium fan that's still quiet around the airport, not going to cause people to call their congressman, but yet efficient enough for high speed as well. So it turns out if you take all those pieces and you put them together and say, well, let's build a supersonic airplane with today's technology, you can do it without having to invent anything new, just kind of using off-the-shelf stuff. And that's what we're doing at Boom. So this is what we think of as the first airplane. It's unlike Concorde, it's quite a bit smaller, so it seats 55. A lot of people say at 100 seats, Concorde was actually too small. In my view, it's actually the opposite. The more expensive an aircraft is to operate, actually the smaller it needs to be, because the fewer the people could afford to fly on it and the harder it is to fill the seats. So we'll be able to hit about business class kind of prices. So think like New York to London round trip for around $5,000. And that means you should size the airplane like a business class cabin out of a Boeing or Airbus aircraft. So 55 seats. If you're an airline and you can fly a 78 or an A350 on a route and make money, well, you can fly a boom jet on the same route and make at least as much money. And that gets you on the happy side of a tipping point. So Concorde made money on like 2 routes, and we think this is going to be economical on about 500, without even assuming any supersonic flight over land. So a completely different kind of economy of scale. Talk about some of those and why we think this is a big deal. So New York to London is that classic Concorde route. Today it's 7 hours, right? And you fly it probably as a red eye. Concorde did it about 3.5 hours, and will be about 3 hours and 15 minutes. And what that means is, if you're in New York and you're going to London, you got the time difference working against you. You catch the first flight of the day from New York, you land in London about 2:15 in the afternoon, which means you have time to get downtown, actually get a couple hours in of meetings, go out to the pub, entertain your clients, and get home in time to tuck your kids into bed. So it's not just like a couple hours less. It's changing what you can do in a day. It's getting you home a whole day earlier. Or across the Pacific, so San Francisco to Tokyo, I did this flight a couple weeks ago. Instead of being about 11 hours, it shrinks to 5.5. So what that means is you catch a morning flight from San Francisco, you get to Tokyo 5.5 hours later, it's morning Tokyo time, your body thinks it's in the afternoon, so you're awake, they're awake, you got a whole morning of meetings, go get some great sushi, and be home by midnight the day you left. And that's like 2 days faster round trip than you can do it. And the itineraries tend to shift from what would be a red-eye flight today that you try and sleep on, and you get kind of like airplane sleep, right? It's not real sleep, to daytime flights, and you get to be awake and productive on the aircraft, then come back and sleep in your real bed, and not an airplane bed. So one more example. I also flew this 2 weeks ago, which is crazy. So LA to Sydney, that's 15 hours. That's like Hawaii before jets. Think about that. It's like, who wants to go to Sydney? It's 15 hours. It's miserable. And with supersonic, that becomes a little bit less than 7. So no offense to our friends down under, but Sydney's going to become the new Honolulu. And think about the second order effects of that in terms of where we're going to vacation, where we're going to do business, where you're going to put factories, where you're going to put remote offices, even who you can fall in love with. So let's shift gears a little bit and talk about kind of some of the design and experience aspects of high speed. People often ask me, well, what's it going to be like to go fast? Does something like scary happen to your body when you go through the speed of sound? And actually, is anybody in the room flown Concorde? All right, we got 2, right? Okay, so you guys can attest, like, it's not scary at Mach 1. In fact, they have to get on the PA system and say, by the way, you're supersonic, and have some champagne. Otherwise, you would have no idea. And in fact, the faster you fly, the higher you go. So we'll be up at about 60,000 feet, above commercial traffic, above private jets. And at that altitude, you can actually see the curvature of the Earth, and you're above more weather. So it's a smoother ride. Concorde, as our Concorde passengers could attest, was kind of like flying Southwest today. It was really, really cool, but not such a great roomy experience. And we have enough, progress in efficiency of the airplane that we can not just reduce the ticket prices by a lot, but also put a much better interior on the airplane. So this is the new business class. My personal favorite feature in this is the cup holder that's nowhere close to the laptop. That would have saved me a few times. Like this morning I was kind of balancing my coffee on the trackpad and like, oh God, if I spill this, I won't be able to give a talk. So nice wide seat. And of course, when the flights that today are 7, 8, 9 hours turn into 3 or 4 in their daytime, you don't need to put a bed on the airplane. You get to sleep in a real bed, so the seats don't recline all the way. They don't need to. The airplane, the supersonic airplane wants to be long and skinny. So you've got one seat on each side of the aisle, which means you don't have to choose window seat or aisle seat. Everybody gets both. Now, some of these specific flights, like the 15 hours that turn into 7 hours, maybe you do want to sleep on the airplane. Maybe that does make sense as a red eye. So you can do kind of a double long configuration, put a lay flat bed in there, get even more space, and sleep on the airplane. So that's, imagine going to sleep in Sydney and waking up in LA. And we've been working on this design, not just in CAD and making pretty pictures, but really working it out physically. So this is a shot of what our hangar looked like a couple of weeks ago. One of the interesting design challenges in this airplane is that, as we said earlier, the shape is really complicated. In fact, it's not a constant cross-section from front to back. So up front, the airplane's actually fatter, and in the back, it's skinnier. So you have to design an interior that works kind of at all scales. And we thought about putting a children's section in the back. That would, some people would really like that, but probably not the best idea. Okay, so that's kind of the production aircraft. Now, I'll talk a little bit about like how we're attacking this as a brand new company. As a startup, it's probably not the best idea to go off and build a 170,000-pound supersonic airplane as your very first thing. So we're starting off with basically a smaller, scaled-down version of the same design. That's the little one on top, the XB-1 supersonic demonstrator, or Baby Boom, as we like to call her. And it's, as far as you can, it's the exact same thing as the production aircraft, just smaller. So same kind of wing design, same materials, same engine intake design. And of course, you have to change a little bit here and there due to scaling effects. We couldn't find any 1/3 scale test pilots. So you have to go to a tandem cockpit and put a bubble canopy on it. It looks more like a fighter, but it's actually an airliner prototype. And that aircraft, we're finished with the design. We're starting to build test parts now, and we're going to fly towards the end of next year. So this speaks to, this is not some sci-fi, we got a technology that's working in a lab, we just got to get it in the air. No, all the constituent pieces exist. We just got to put them together and make it fly, get the engineering done. I'll show you some cool real-world pictures. This is the last wind tunnel test that we did in July in the Nayar tunnel at Wichita State. And you can do some neat visualizations. Put smoke down the wind tunnel, drop a sheet of laser light in there, and see exactly the pattern of airflow over the wings. So that really cool swirling, that's called vortex lift. Supersonic airplanes generate lift completely differently from subsonic. And when we did this at Nayar, the kids who were running the wind tunnel, the students, had never seen a supersonic airplane in the tunnel before. And they said, wow, it looks just like our textbooks. And we said, whew, it looks just like the textbooks. So that was a relieving moment. And here's some of the hardware that's coming together now. So this is a wing spar, completely made out of carbon fiber composites. This is the thing that basically carries all the loads from the wing into the fuselage. And we're building test parts, pulling on them, making sure we're getting the strength we need before we actually go build the airplane. So that's most of what I have to say about the airplane and a supersonic future. But I wanted to have just a few thoughts about airports and how the supersonic age is going to impact airport design. And especially with this group, I feel like I'm way out on a limb on this. What I know about airports is what I know as a passenger going through them. So take this as like one guy's perspective on high-speed future for airports. I think back about kind of the golden age of jet travel and how we used to do airports. Of course, they were absolutely beautiful. And what I find is really interesting is because they were smaller and the passenger volumes were smaller, they were really easy to make efficient. The TWA terminal, you walk through and you go down through the passageway and onto the jetway. I think this was actually the very first terminal that had enclosed jetways. But it didn't take very many minutes to get from the curb to your airplane. And of course, back then we didn't have the TSA. And so the experience of going through this was a beautiful, inspiring architecture and not a whole lot of time. And today, in this world where we've kind of given up on speed and we've changed the way airports get paid for, they get, as we know well in this room, they get turned into malls, right? And we design them to keep you in them longer and spend more money because that's how we pay for the airport. And this shot's, of course, from Heathrow, where I guess we try to keep everybody congregated in one place where the stores are, and then you spend like 20 minutes getting to your flight. And this makes sense kind of in today's model where long-distance transportation is something you don't do as frequently, something that's a bigger event, an experience in and of itself, and you spend a lot of time in the airport, especially if you're connecting. But what about in the future when flights are faster and you can go more places more of the time? What's the right vision for an airport? Does an airport become a destination, or should it recede? Should it be like a magic portal to the planet that you don't even notice when you're going through it? And in my view, like at least as one passenger, like that's what I want. And I think it's interesting to kind of look at what goes on in private aviation. When you've had a lot of these constraints removed, what do we drive to? Well, you can literally drive up to the airplane and walk on. And this doesn't scale for millions and millions of passengers. But I think this is, in a way, it's an aspirational idea for design. How can we make it such that everyone can have an experience about as good as this? Where you don't think about going through the transportation system, you just think about where you're going and getting there, getting to be there on the ground. So that's I guess the design challenge that I think we have in the high-speed era. And I'm going to close with just a little video that we made about why we get inspired to work on this every day. And then we'll have a few minutes for questions.
The pursuit of speed is often relegated to the adrenaline seekers, the risk takers, the record breakers. But our pursuit of speed is about something greater. It's speed in service of the experiences that make life precious. Imagine, if you will, flying across the Atlantic, doing business, and being home in time to tuck your children into bed, or where New Zealand becomes as accessible as New York. What would that do for families, for culture, for business? The technology for supersonic flight has existed for over 50 years.
This is the new supersonic airplane.
But it was too expensive for routine travel. At Boom, we are refining it, perfecting it, so that high-speed travel can be available to anyone. In the digital age, there really is no more distance. There is only time. Time from one another. Our mission is to remove that barrier, meaning more meetings in a day and more nights with loved ones. Where children grow up with their parents at home, and where relationships are no longer considered long distance. We see New York to London in 3 hours instead of 7. San Francisco to Tokyo in 5 hours instead of 11. We see world leaders spending more time in the same room, the acceptance of cultures, and the spreading of ideas. At Boom, we see the time saved as really the least important part. This isn't about time saved, it's about life gained. Together, we can make cities into neighborhoods and make the world a smaller place. Boom. The future is supersonic.
Well, thank you very much. I think we have just a minute or two if there are questions. Yes?
From an airside planning standpoint, looking at the extended tail section, but the sort of stubby, does it fit into a Group 3A?
It'll fit into a narrow body gate. So if you can put an A320 or 737 there, you can put Boom Jet there.
Okay.
And that's, we're very much by design, it's not another A380 where you got to go redo everything. It should be easy for airports to adopt, easy for airlines to adopt. And of course, you can do something custom, but you don't have to. In the back?
Without giving away any secrets, can you give a kind of breakdown of the cost of operation for the ownership of the equipment, the fuel, and the operations, either on a some breakdown just to get an idea of what's different now versus what when we were, what the airlines were running.
Right.
This was going around the first time.
Okay, so the question is, without giving away any secrets, what's the delta in operating cost breakdown and why does this work now? I give an indication of it. So the big challenge as you go faster is fuel efficiency. Concorde was a gas guzzler, and also with 100 seats and working only a couple routes, the utilization was horrible. So the two big leverage points relative to Concorde are getting the fuel burn down, and then getting the utilization up. Let these aircraft work 14 hours a day, just like we would our subsonic fleet today. But thanks to kind of more route structure, higher availability of the aircraft. And when you run all that out, you get to a cost per available seat mile that's about the same as subsonic business class. So you can charge the same fares, make the same great margins, or if people paid a premium for speed, the margin actually goes up. Yes?
Yeah, thanks for a really interesting presentation. Thank you so much. Thanks for an awesome presentation. I mean, I think as you said, the sort of secondary effects of this are really staggering. I mean, I think about things not just about time, but also about the real estate market in some of these cities we've been talking about. I just have two really quick questions. One is that a lot of these previous breakthroughs that you showed, jet technology or the Wright brothers, they happened at a time when there wasn't a lot of already sort of built investment in infrastructure on the ground. So it was a lot easier to adapt to this. And I guess this gets back to the first question, which is, how, when you're approaching airports, how can you convince them that this is something that they should be embracing rather than resisting? Because I could just imagine there are going to be many companies, many authorities out there who have a vested interest in trying to make this not happen. So that's, I guess, the first question. The second question is, there's so much chatter right now about the potential effects of unbundling in the business class industry, and thinking about what unbundling did to economy in terms of the introduction of low-cost travel, and that would significantly bring down the price point of a business. So I'm just wondering how you're kind of conceptualizing that challenge as well.
Okay, so what's the airport response, and what about unbundling, and how does that impact the economics? So airport response, I've yet to meet a single airport that doesn't want to have supersonic service. The response, and then they say, well, do we have to do anything special to support this? And we say, no, by design. And then they say, oh, but think of the special things we could do. That's the typical response. Especially as you think of coastal airports, like Miami is a great example, ideally geographically positioned to be a supersonic to subsonic connecting hub. They get really excited about that idea. So I think what you'll see is some folks wanting to do something custom, but nobody needing to, and everyone kind of wanting to have higher speed service into their city, because it's also going to drive passenger volume increases, and that's good for everybody. So B, what about unbundling of business, and how does that affect the economic model? So this is like real crystal ball kind of stuff, but I'll tell you what I see in mine. You believe history, when flights get faster, more people go more places. And so ultimately, I think there's going to be a question of how do we have enough supersonic capacity to meet demand, but which will push up kind of the clearing price of supersonic in the short term, when it's supply and demand are out of equilibrium. But I think what you'll see is the airlines, they'll be like the haves and have-nots of supersonic, and the folks that have supersonic fleets will basically densify their subsonic fleet, go more economy, and then move the premium passengers into the high-speed fleet. And you can still have that premium subsidizing economy, but kind of across two aircraft. And where it's going to really be challenging is for the operators that don't have supersonic. I think in subsonic, there's going to be a bias towards low cost, and the folks that are having low-cost models for international are going to have a big advantage in subsonic when the premium passengers are starting to move to a different fleet. And that happens for, call it, one generation of aircraft. And then the second generation of supersonic happens. It's a larger aircraft. It's got new tech on it. It's more affordable. And then you start to have premium economy and economy moving to higher speed. I think we'll see that in our lifetime. There's nothing physically impossible about it. You've got a bigger aircraft, put a little bit of new tech. And the gentleman was asking before about kind of how the economics tip out. Well, fuel's the challenge when you go faster, but utilization actually saves you. So you can do 2 or 3 times the flights with the same crew and hardware. So you make enough progress on fuel economy, there's a tipping point where the utilization benefits, think of it as like the speed dividend, pays off, and then the whole operating cost on a per seat mile basis can actually be better high speed than low speed. So at that point, then the subsonic fleet, I don't know, it turns into cargo or something. I don't know how much time we have for questions. Maybe one more? Any more questions? Oh, that's too intimidating, apparently. Okay, yes?
Any plans to sell the Baby Boom?
Any plans to sell Baby Boom? My guess is it'll end up in a museum. If the question's, are we going to make these and sell them as a product, it's kind of a hot rod airplane. It's an experimental design for a professional test pilot to fly, not for an amateur pilot. You can't fly it supersonic over land. So there's kind of not a lot of commercial opportunity for it. It's really a technology demonstrator, and we'll go put it someplace where you can go check it out when we're done with it. All right. I think I should wrap here. So thank you very much for being an awesome audience. Really enjoyed chatting.